I know some people had a couple of questions over those limit problems for homework, so I'm going to give you the answers, but I also wanted to show you some worked out solutions to a couple of those trig limits. To start off with, here on number 3, we've got limit x goes to 0, sine 2x divided by x. Well, the problem is we don't have 2x in the bottom. Okay, well, what we're allowed to do is multiply the bottom by a 2, just as long as we multiply the top by a 2. So that can be rewritten as 2 times the limit, because remember, constants can be factored out in front of our limit. So 2 times the limit x goes to 0 of sine 2x over 2x. Okay, well, now that we have sine of argument over the same thing, and that thing is going to 0, as x goes to 0, 2x is also going to go to 0. So we get 2 times 1, which is just a 2. On the next one, we've got sine x over 2x squared minus x, and we're taking the limit as x goes to 0 again. So I'm just going to do some factoring. Limit x goes to 0. Top, not much I can do. Bottom, I can rewrite as x times 2x minus 1. And I'm going to change this to a multiplication of 2 fractions instead of 1 fraction. So that's sine x over x times 1 over 2x minus 1. And we're taking the limit of that whole thing. Well, if the limit of each of them exists, one of those properties is we can do limit of first times limit of second. The limit of this one is a 1. The limit of this one, as x goes to 0, is a minus 1. So we should get negative 1 there. Number 5 is another fraction. We just want to split that into 2 pieces that are adding. So that'll be limit x goes to 0 of x over x plus limit x goes to 0 of sine x over x. Anything over itself is a 1, except 0. We don't do 0 over 0. Limit of sine x over x going to 0 is a 1. So that'll be 1 plus another 1. So you get 2. On number 6, we're going to do some factoring. I'm going to rewrite this as limit x goes to 0 sine x over x times sine x over 1. Because sine squared x is really the same as sine x times sine x. Getting a sine x infection here. So same story. If the limit of each exists, then we can multiply the limit values. That'll be a 1 times, well, as x goes to 0, sine of x is going to approach 0. So you're going to get a 0. Number 7 was really tricky. First thing I'm going to do is move that 3 out front, because that's a constant. And so next I'm going to write a big fraction. 3 times limit x goes to 0. The top fraction will be sine of 4x over 1, and the bottom one will be sine of 3x over 1. Alright, well, problem here, I get 0 over 0. That is something we call an indeterminate form. If I had a 4x there, that'd be good. And I would also have to have a 3x down there. Well, I can do that. I'll multiply the bottom by 4x, just as long as I also multiply the top by 4x. And you could probably guess what I'm going to do down here. Basically the same thing. And, okay. Now what we're going to get is 3 times, well, the limit of this as x goes to 0 is a 1. The limit of this as x goes to 0 is another 1. And I have x over x, so I'm left with 4 on top, 3 on bottom. Cancel some common factors, and then bam, you get a 4. The last one was also pretty tricky, number 8 here. What I did was I multiplied by 1 plus cosine x on top and bottom. That gives me the limit, x is going to 0, x squared times 1 plus cosine x. And then in the bottom, that is a difference of 2 squares, so I get 1 minus cosine squared x. Oh, that sounds like a Pythagorean identity. So that's limit x goes to 0, and I'm going to write this as x squared over sine squared x. And this factor here, I'm just going to write multiplying to the side. Okay, well, I don't really have the thing I need, because it's supposed to say sine of thing over that thing. Well, if I have the reciprocal, though, I can write that as 1 over. So that's limit x goes to 0 of 1 over sine squared x over x squared times 1 plus cosine x. Running out of room here. So let's see, the next step, what I could do is, and that's taking the limit of that entire thing. Next I'm going to get limit x goes to 0. And I'm going to write that as 1 over sine x over x times 1 over sine x over x. Because each of them is squared, the square means multiply by itself. All times 1 plus cosine x. And so again, I'm just going to do limit piece by piece. If the limit of each thing exists, I can do it numerator by numerator, factor by factor, so on and so on. So the limit of the top is a 1. The limit of that is a 1. Limit of top is a 1, limit of that is also a 1, and as x goes to 0, 1 doesn't change, but cosine x is going to approach a 1. So I get a bunch of 1s times 2. That's it.